Okay, good morning all of you. पिछले क्लास में what we have done, we have understood the different layer of the sun. So let me revise once again. Here we have one structure of sun. In this sun, can we say that the middle one, this part, this is known as crowd. As we discussed in the previous class, this is the crowd part, and just above that, can you see this one, this part? This is the zone of radiation. This is the zone of radiation. This is the revision of the previous class. This is the zone of radiation. And the third part, can you see this part? This is the zone of convection. This is the zone of convection. उसके बाद this layer, can you see this one? This part, ये जो दिख रहा है, this is the photosphere. This is the photosphere. And after that, the middle one, this part, let me take this little bit more. And this part, this is the chromosphere. This is the chromosphere. And the outer part, this part is called corona. So, and we have discussed some of the things like here, zone of radiation we have discussed, zone of convection we have discussed, corona we have discussed. Now today we are going to discuss about the atmosphere of the sun. What we are going to do, we are going to discuss about the atmosphere of the sun. And what are the atmosphere? In the atmosphere, three things come: photosphere, chromosphere and the corona. So one by one we are going to discuss. And what are those? The first thing that we are going to do about the photosphere. So let us go ahead with this. The first topic that we have are the atmosphere of sun. Atmosphere of sun. So when we talk about the atmosphere of sun, the first we need to discuss about the photosphere. First we need to discuss about the photosphere. So this is the atmosphere of sun. So there are not too much we need to know about the atmosphere. Just 2 or 3 points we should know about this. The first point that we are going to discuss, that is the surrounding the zone of convection. Means, let me write first, this what it will do, it surrounds the zone of convection, surrounding of zone of convection, as we discussed in the previous class also, like the layer that is available around that. See here, can you see this? In this part, in this figure you can see here we have zone of convection, and around that zone of convection, around this zone of convection, this is the zone of convection, and in this zone of convection, after this is the present, and this is what? This part is a photosphere that I am highlighting right now. This part is a photosphere. So in the atmosphere of the sun, the photosphere, how we will define the first point, the surrounding of the zone of convection. Now, the interesting part is that this photosphere we can see by our naked eye. So the second statement we can write, visible part of the sun, visible part of the sun, visible part of the sun, and can be seen by our naked eye, naked eye. So it can be visible. The important thing is that whatever layer is present as an atmosphere of the sun, we can see all. Like you can see the photosphere also, you can see the chromosphere also, and you can see the last one, that is corona also. So but right now we will discuss about that also, but right now we are discussing about the photosphere, surrounding of zone of convection, visible part of the sun, and can be seen by our naked eye. This is the second part. Now when we talk about the third one and the simple one, average temperature. As I told you in the previous class also, as we move away from the core of the sun or center of the sun, the temperature start decreasing, and it's a natural phenomenon also, it's a natural things also, it's very easy. Like as we move away from the center of the sun, it start decreasing, temperature start decreasing. And what is the actual temperature of the center of the sun? That was approximately 1.5 degrees Celsius to 2.5 degrees Celsius in crore. In CR means 1.5 crore degree Celsius to 2.5 degree crore Celsius. So this is the maximum temperature which is available at the center of the sun. So what is the average temperature of photosphere? Average temperature of photosphere is approximately 6000 degrees Celsius. Okay, so this is the atmosphere of sun. In the photosphere surrounding the zone of convection, visible part of the sun and can be seen by our naked eye, an average temperature approximately 6000 degrees Celsius. And there is another important point. And what is that important point? In this photosphere there is one term that is called sun spots. Sun spots. These sun spots are available in the photosphere. Now the question is, what is this sun spots? You may ask, what do you understand by this sun spots? This sun spots, listen, as you move away from the center, right, the energy will also move away from the center, like, because energy gets what split up into the hydrogen get combined and form the helium, and the helium start moving all around. Like if it is a center, so what will happen, from here the energy will start moving. So if the energy will start moving, to where it will go? It will go out of the center of the sun, right? So it will move towards the photosphere, it will move towards the zone of convection, it will move towards the external part of the sun. So as it move out of the core, somewhere in the photosphere get accumulated. What it does, it get accumulated in the photosphere, and that accumulation of that energy form sunspots, right? So now if it is a made up of energy, so can we say that sun spot is also a source of energy? Very easy. Can we say that sun spot is also a source of energy? So here we can write sun spot is also a source of energy. The first thing you should know how it forms. Right now I explained you the accumulation of different energies. So sun spot is a source of energy, first point. Now when we talk about the another thing, can you tell me what is the place of this sun spots? The sun spot is formed in the photosphere, so we can write it is available in sunspots, it is available in photosphere, right? So can we write this, it is available in photosphere. Now how the question will come, this question may come as a prelims, in the prelims also, like 4 option will be there, very well. So 4 option wise it can come as a MCQ also, and it can come in the mains also, like explain each and every layer of the sun, or give your thought, your comment on the structure of the sun. So there this concept will help you to explain the different layer of the sun. To sunspots, what you have to write, source of energy, it is available in photosphere, right? How it formed, the accumulation of accumulation of energies, right? So when you will do the examination, when you will give the examination, try to make the things concise, but it should have very good impact. Means the word selection should be very good. You give your knowledge in a very short way. That is why there is a time limitation, because you cannot write everything. Like there is a 20 marks question, then you will get only 2 pages. Now in that 2 pages or 3 pages, you have to give your all the things that you know about that questions, the concept that you know, right? So you have to be very specific about the word. So whatever you write in a short, but your impact of that word should be very good. Like you have seen NCRT. NCRT is a very compact book, but the word selection they do is a very good, right? So in that way you see that is why reading NCRT is a very important, because that NCRT will tell you how to write the answer in the examination. It is not, see, the content that is available in the NCRT, that very good content is available in another book also. But why we need to study only NCRT? Because the NCRT will tell you how to write the answer in the mains examination, right? So focus on the NCRT also. Okay, we are diverting from our topic, so let us come inside this topic. It is available in photosphere, the second topic. And the temperature of this sun spots is a little bit less than the photosphere, that is approximately 4400 degrees Celsius to 4600 degrees Celsius. This is the temperature of our sun spots. And this sun spots, the first we have done formation, second we have seen that what is the sun spots, formation, temperature. Now the question is, sir, what is the life cycle of this sun spot? Like it gets destroyed in a second or it gets destroyed in a month? So no, the life cycle of this sun spot is approximately 11 to 12 years. The life cycle of this sun spot is approximately 11 to 12 years. Means one it formed, life cycle is approximately 11 to 12 years. Means once it get formed, it will get destroyed after 11 to 12 years. So this is a MCQ based question. So remember these kind of things. So life cycle is approximately 11 to 12 years. Now the next thing, now this sun spots can be of two types. This sun spots can be of two types, because let me explain you with the help of this. See, sun spots can be of two types. How can we say that sun spot is of two types? See, sun spots is the accumulation of energy, right? Sun spots is the accumulation of energy, but somewhere what happens, there can be a maximum energy, right? Because there is accumulation na. So if there is a maximum energy and somewhere there may be a minimum energy, right? Maximum and minimum energy may be there. So what will happen if somewhere is a maximum energy and somewhere is a minimum energy, right? So if there is a maximum energy, that point or that place is known as maxima. That known as a maxima, means solar maxima. That is known as solar maxima. And if there is a minimum sun spots, then that is called solar minima. This is the second concept that we need to understand. The first one, solar maxima, and the second one is solar minima. Now when you will see this solar maximum, solar minima, you will get what is this solar maxima looking like a very good bird, like कौन सा rocket science है ये, कितना बड़ा word है, भारी भरकम. But it's not like that. Solar maxima means the sun spot where the maximum energy is present, and the sun spot where the minimum energy is present, that is called solar minima. So these two concepts, I think it's a very rare. Now the next thing is when the rate of formation of sun spot is maximum, then the emission of heat from the sun is also maximum, right? Now what happens, let me again make one diagram for you all. See what happens when we talk about the sun spots. Let us suppose here we have one solar flare, here we have one solar flare, here we have one solar flare. And what happens, the energy will increase, energy will radiate, because this is also source of energy na. So here the energy will come out. So if there is a maximum energy, then the emission of heat will also maximum. The emission of heat is also maximum. If there is a emission of heat is maximum, then what will happen? From here this energy will start moving outward. This energy will start moving outward. And what will happen when it will start moving outward? What will happen? This energy flow in the form of flares, and that flares is known as solar flares. This is known as solar flares. So now again you can check this. If there is a if there is a solar maxima, then there will be a high solar flares, and if there is a solar minima, there will be a low solar flares. Now here high solar flares and the low solar flares. Now coming back to the next point. Now once we have done this topic, so now again 2 points happens. Now let us suppose here we have one earth. Let us suppose here we have earth. Now in earth we know that earth behave as a magnetic field. Earth behave as a magnetic field. Try to understand this concept. If earth behave as a magnetic field, so what will happen? Let us suppose from here we have one solar maxima or solar minima, and the solar flares is coming out from here. What will happen? The solar flares is coming out from here. Solar flares is coming out from here, right? So can you see this? When the solar flares is coming out from the sun spots and it is hitting on the earth, so what will happen? Earth maybe get destroyed, but still earth is existing. We are on the earth. Why? Because of this magnetic field. Because what happens when the earth is available here, what happens? It creates their own magnetic field like this. What it does? It creates magnetic field like this. It creates magnetic field like this. And when it creates magnetic field, whatever solar flares is coming, let me erase this first, then you will get understand. Whatever solar flares is coming from here, it gets diverted. It doesn't come in the earth magnetic fields. It get diverted in this direction like this. It will come here and it will get directed like this. It will go like this. Again it will come like this and it will go like this. So there is a very important work of our magnetic field. So magnetic field does not allow the solar flares to come on the earth, because if the solar flares will come on the earth, what it will do? It will destroy the earth, and that is not possible because of the presence of magnetic field of the earth. So there we have to be very proud that earth save us. So it is our responsibility to save the earth also. So now solar flares we have done. Now when you will observe these solar flares, when these solar flares move from here, that I am doing right now, the green arrow, when it moves from here, it creates a light. And as we know, this is the which pole? This is the, tell me, and this is the north pole and this is the south pole. So these solar flares create light at north and south pole, right? And this is known as polar light. This is known as polar light, and the another name of this polar light is aurora. Another name of this polar light is aurora. So now if it is formed in the north pole, if it forms at the north pole, then it is known as solar aurora borealis. If it forms at the north pole, then it is known as aurora borealis. And if it is formed at the south pole, if it is formed at the south pole, then it is known as with the another name, that is called aurora australis. Yes, australis. First aurora borealis, and if it is visible in the south pole, then it is known as aurora borealis, right? So this is whole about the sun sports and the photosphere. Now coming back to the last 2 points, I will not take much time, just 5 minutes. Now coming back to the next point, that we have chromosphere, the another part of atmosphere of sun, that is chromosphere. So when we talk about this chromosphere, what happens? Again, the same statement you have to write surrounding the, tell me, now you can answer, surrounding the photosphere. Surrounding the photosphere. Surrounding the photosphere, first topic, first point. Now second, this is the atmosphere of sun. Chromosphere is a atmosphere of sun. Now the third point, what we'll write, when you will see, chromosphere is not visible, all like the photosphere like chromosphere also visible by the naked eye, but you cannot see always. Why you cannot see always? It is always visible during the eclipse only. You can see it's seen in eclipse. And what is the color of that eclipse? Not eclipse, the chromosphere. When you will see in the eclipse, the chromosphere will look like light reddish color. Light reddish color. When you will see the chromosphere during the eclipse, it looks like a light reddish color. Okay, and if I am talking about the eclipse, so there are two types of eclipse: lunar eclipse and the solar eclipse. So in which eclipse it is visible? It is visible in the solar eclipse, right? So this is all about the chromosphere. Now the last one, that we are going to discuss about corona. Again 2 to 3 points, not more than that. So when we talk about the corona, the first, most outer part of the sun, most outer part of the sun. What is that? Most outer part of the sun is the corona. Again, it's also known as crown of the sun. Why it is known as crown of the sun? Because it is available outside or outermost part of the sun, and it looks like a crown. So also known as crown of the sun. And the last point that we have, it is also visible through the naked eye. Visible but not always, only in the complete solar eclipse. Only in the complete solar eclipse. So this is all about atmosphere of sun. So now thank you so much for joining us. Bye bye.